we're going to introduce a term, permutation. A permutation of a set of objects is just an ordering of the objects in a row. Now, how many permutations does a set of n objects have? Now you just think about how many ways to arrange, to order n objects. Say suppose there were n objects, and then we are going to order them, see how many ways to order them. The number of ways to fill in the first, to pick one object to place in the first will be n number of ways because we have n objects. Once the first one is chosen, we are left with n minus 1 object to choose from. So therefore, for the second one, there will be n minus 1 ways to choose from. And similarly, n minus 2 ways to choose for the third one, and so on and so forth. So you can imagine that according to multiplication rule, how many ways to order n objects, it will be like keep this pattern until you fill them all out, right? So therefore, this is going to be n factorial. This is what the theorem 9.2.2 says. The number of permutations of a set with n elements is n factorial. And here are some examples. How many ways can we permute the letters in the word computer? There are 8 letters here. The permutation, that means how many ways can we order them? According to what we just discussed, this is just 8 factorial because there are 8 different letters. You can also imagine like there are 8 letters, and then how many ways to fill in the first one? There are 8 ways. Once the letter is used, the next one, you have 7 letters left, and then 7 ways to fill in the second one, and so on and so forth, right? 3, 2, 1. So therefore, it's going to be 8 factorial, which is a pretty big number. Now the second, how many ways can we arrange the letters in the word Juan? There are 5 different letters, so therefore we'll say 5 factorial. What if we say an has to, these 2 letters have to be together and in this order, an, not na. In this case, how many ways can we rearrange the letters in this word Juan? With this restriction, an must be together. The trick is, think of this as one object. An have to be the stick together in the same order. So think of this as one object. So then you have 1, 2, 3, 4. 4 objects to permute, right? So in this case, the correct answer will be 4 factorial. Now let's look at another example. How many ways can we seat 6 people on 6 seats? And these seats are in a straight row. And this is pretty straightforward. This is actually 6 factorial. Now, how many ways to seat 6 people around around a circular table? So like this is a circular table, and we are going to seat 6 people around here. It may be very tempting to say 6 factorial, just like what you do earlier. However, this is incorrect. This is a little tricky. The reason is, if you think of 6 factorial, you're going to overcount. For instance, I'm going to say, suppose this is seats 1, 2, 3, 4, 5, 6. Suppose we have these 6, 1, 2, 3, 4, 5, 6 seats, right? Now, if you arrange, say, A, B, C, D, E, F, say we have 6 people, A, B, C, D, E, F. Now, if you arrange it this way and arrange it this way, suppose A, B, C, D, E, F, the green seating arrangement and the red seating arrangement, obviously A has taken different seats now, and in this case, they will be considered as the same seating, like because A's neighbor is the same as the red seating, A's neighbor is the same as the green seating, they consider to be the same seating. So if you do it that way, you're counting these as different seating. However, they're considered to be the same. Now, how do we correctly count how many different ways to seat these 6 people, think of it this way. So you can think of fix A to sit on seat number 1. So A is here. Once this is fixed, just rearrange all other 5 people using the permutation. So in this case, your answer actually will be, because this is already fixed, we don't have to find a seat for A. So there were 5 people remaining, so we'll have 5 factorial to count how many ways to sit 5 people. So this is a little tricky, and hopefully that makes sense to you. So be careful not to overcount. Now, an R permutation of a set N elements is an ordered selection of R elements taken from the set of N elements. The number of R permutations, this is called R permutation. Basically, you have N elements available, but you're not gonna order all the N elements. You're only order part of the N elements, say R elements. And then how do we find the R permutation? By the way, it is denoted by P of the parentheses N comma R parentheses. And there are different ways to read that, but basically this is the number of R permutations on N sub-object. It is computed by 2 ways. One is N times N minus 1 times all the way down to M minus R plus 1. Or you can use M factorial divided by M minus R factorial. And they're equivalent because this one, you can see that if you expand this guy, it's going to be N times M minus 1 times M minus 2 times M minus R plus 1 times M minus R factorial. And the bottom one is M minus R factorial. They can cancel out, right? So therefore, you get this one. To me, this is more intuitive. This is more intuitive. Now let's talk about how we compute that guy. I'm gonna give you a little more context for understanding this guy. Say suppose we have 10 students, say 10 students. And I'm gonna give, say, 4 prizes. The first prize, second prize, the third prize, and fourth prize, right? And then how many ways can I award 4 different prizes to 4 students out of the 10 students? So how many ways can we award the first prize? There were 10 ways because there were 10 students, right, for me to choose from. Now, the student receiving the first prize will not receive any other prize, so that student will not be available for me to choose for the second prize. So I have 9 students to choose from for the second prize, and 8 students to choose from for the third prize, and 7 for the fourth prize. So this is basically what it is: 10 times 9 times 8 times 7, or whatever this number is. Or you can do it this way: 10 factorial. 10 minus 4 factorial, which is 10 factorial over 6 factorial. And if you expand that and cancel out the 6 factorial, that's what you have. Okay, so that's the first one. I'm going to move this to the side. And this turns out to be 50/40 if you do it on your calculator. How many 6 permutations are there of a set of 9 objects? So this is the permutation of the 9, 6. Okay, so this is going to be, so this is what I do. This is another trick. So when you look at this look back here, 10 permutation, 10, 4, the R is 4. You're going to start with 10. And there should be 4 numbers to multiply. So 10, down 1, and down 1, just multiply 4 numbers. So that's a good way to remember how to multiply. So here I have the permutation, 6 permutation of the 9 objects. So therefore I have 9 times 8 times 7 times 6 times 5. Do I have enough? I count 1, 2, 3, 4, 5. Not yet. So times 4. Now I have 6 numbers now. Okay. So that's how I would compute this one. This is turned out to be 60,480. How many ways to form 5 digits number if no repetition is allowed? Okay, so I have 5 digits number. So I'm gonna. How many ways can I fill in the first digit? Because for this to be a 5 digits number, the first one cannot be 0, right? So therefore, I have 9 numbers to choose from for the first one. So this is going to be 9 ways to choose 10 digits, but the first one cannot be 0. So therefore, you can choose 1 to 9. So 9 ways to choose the first digit. Now for the second digit, we can certainly fill in 0 now, but 1 is used in the first place. So we are down to 9 digits available to fill in for the second digit, right? So therefore 9 ways to fill in the second one. And 2 numbers are used. Therefore, by the way, I just want to be sure this is a non-zero digits to be the start with. And 1 non-zero digit is taken, and here the second one, 0 is available for you to choose, plus 8 non-zero digits for you to choose from. That's why the second one is also 9. Now the first 2 digits are chosen. How many ways for us to choose the third one? We are left with 8 numbers to choose from, and 7 numbers to choose from for the fourth one, and 6 numbers to choose from for the very last one. Okay, so again, multiplication rule is still used. You have to do it step by step, right? Break down this whole task into steps. So this will be turn out to be 27,216 number of ways. 11 should be pretty straightforward. So how many different words can be made using 3 of the letters from Jacob? There were 5 different letters here, so 5 different letters here. We want to form a 3-letter word using these 5 letters. So the 5 times 4 times 3. Basically, this is a 3 permutation of 5 objects. All right, let's do some drill exercise. 3 girls, let's call them ABC, and 3 boys, call them DEF. They are to occupy 6 seats in a row. So this is not a circular table scenario. It's just 6 seats in a row, in one row. How many ways can this be done if any order is allowed? So this is actually 6 factorial, right? 6 factorial because 6 seats. First way to fill in the first seat is 6 ways to fill in the first seat, and 5 ways to fill in the second seat, and so on and so forth. So it's going to be 6 factorial. Now, what if it must alternate by gender? So in this case, say if this is male, then this has to be female, and then you have to alternate by gender, right? Now think about, or it could be like female, male, female, male, female, male. So 2 scenarios. Let's look at the first scenario. They're symmetrical. You just find one and then you can multiply by 2. So the first one, how many ways to choose a male to fill in the first seat? We have 3 males, so it's going to be 3. So this will be 3 ways to do that. And how many ways to fill in the second seat with a girl? We have 3 girls to choose from, so this will be 3 times. Now for another, the third seat, which is a male, 1 male is taken the first seat, so therefore we are down to 2 male to fill in the third one, right? So similarly, 2 male, 2 female to fill in the fourth one, And lastly, only one male left and only one female left. So that will be how many ways to seat these 6 people, like male, female, male, female, male, female. So therefore it's going to be, and then similarly for female, male, female, and starting with female, this will be identical. So we just can do that 2 times this guy, 3 times 3 times 2 times 2 times 1 times 1. So that's how we find number of ways to seat them, alternate by gender. Now what about must have a boy at each end? So again, so here this has to be a boy, this has to be a boy, right? So how many ways to fill in the first boy on the first seat? 3 ways, okay? And then step 2, how many ways can we seat another boy here, because we have 2 boys left, so therefore this will be 2, right? 2 ways. For the rest of those 4 people, we really don't care, so therefore you just, that's where the permutation, 4 times 3 times 2 times 1, and then times 2 times 3 at the first and last. So therefore this is going to be 3 times 4 times 3 times 2 times 1 times 2. That's how we find the permutation for this scenario. What about A and B insist to sit together? Okay, so what about they insist to sit together? So therefore, so think in this case, instead of writing 6 seats out, I think I can just say pretend A and B are together, and therefore they can be thought of as a unit. So and then I just need to seat these 5 objects, right? Seat 5 objects. But of course, A, B can be, because they just need to be seated together, it could be also BA. That will be considered as a different arrangement. So I just need to place 5 of those and then multiply by 2, because there were 2 possibilities of that, right? So first, step 1, I'll think of this as 1 unit. And then I place them like 5 factorial, because there were 5 seats available. Think of this as 1 unit, 1 seat. So 1 special seat. So 5 factorial. And then because A, B, and BA, they are different, there were 2 possibilities. So I'm going to multiply this by 2. Multiply this by 2. So this is how I would consider this scenario. Now let's close the section by doing another problem. How many integers from 1 through 2000 contain the digit 6 exactly once? Okay, so think about 1, 2, 3, 4. We have 4 kind of 1 through 2000. The most, the highest number is just 2000, right? So 2000. Now, I will think of this, break this into the following task. My step 1 is to choose a blank for my digit 6, for digit 6. Obviously, 6 cannot be here, because we are thinking about integers from 1 to 2000. If 6 is in the first place, this will be more than 6,000, which is not in this range, right? So 6 needs to be in here or here or here. So 6 can be in, 6 is here, one of those 3. So therefore, how many ways can we achieve the step 1? 3 ways, right? 3 different ways, because can be only in one of those 3. Now step 2, you're gonna fill in the rest of the blanks, okay? So step 2, fill in other blanks. And then how do you do that? So imagine 6 is in one of those, 6 in one of those. And then how many ways for you to fill in the first first place, and because it's from 1 through 2000, here the number of ways you can fill in is 0, 1, or well, 2000 is just the 2000 cannot have doesn't have any 6, right? Doesn't have any 6, so I'm not going to consider 2 to fill in here, because filling in 2 here, there's no way you can get a 6 in this number. So therefore, how many ways can you fill in the first one? You may think 0, 1, 2, but we should rule out the 2, just like I said. So 2 ways to fill in the first one, 0 or 1. Now, how many ways for you to fill in the second one? You can say 0 to 9. There are say one of those is 6. So you cannot fill in. So suppose this is 6. Okay, suppose this is 6. Then you have 9. Oops, I'm not going to write 6 here. Suppose 6 is in here, then you have 9 ways to fill in this guy, okay? 9. Sorry. Suppose 6 is here. Suppose 6 is here, then you're not going to fill in anything in this spot. Then you're going to fill in the rest of those 2. And then how many ways can you fill in this? 6 is taken. And then we do allow repetition. We are not saying that other digits cannot be allowed to repeat. Other digits can repeat. So therefore 6 is gone. You have 9 ways to fill in here. So suppose 6 is in here, then we do not fill in here. This is only one way to fill in there. And similarly, for the very last one, you have 9 ways to fill in the very last one, right? So therefore, for step 2, total, you have 2 times 9 times 9. Now, this is a 2-step process. So therefore, the total number of ways will be 3 times. So this is from step 1, 2 times 9 times 9. This is from step 2.